I'm going to talk about introduction to server-side Swift and Kitura and Swifter frameworks. But before that, I want to quickly talk about WebSockets also in the Swifter framework. So in Swifter framework, there is a function. There is no class or something. There is only a function, WebSocket function. In Kitura, if you remember, we used to have a service which should implement WebSocket service protocol. And there were 4 functions: connected, disconnected, message received in data format, message received in string format. In here, in this function, WebSocket, it's kind of similar. It is also having, it can take 5 parameters. This WebSocket function can take 5 parameters, and all those are of closure types. So basically, all those will be actually called when these things will happen with your connection. So first is whenever you will receive message in a text format or in a string format. The other one is in binary format. Whenever there will be a ping from a client connection, whenever the client is connected, and then whenever the client is disconnected. So there are 5 things: connected, disconnected, pong, message received in binary, message received in string format. All these are passed as a parameter to this WebSocket function, and all these are closures. So there were 4 functions, protocol functions, that need to be implemented if you want to handle WebSocket connections. So you need to implement that service. Here you need to just pass these closures directly into this function, and they will be called accordingly whenever at that stage, at that point of time, whenever that thing happened, like whenever the connection happened or disconnection happened, and so on. If you remember, there we have to use a WebSocket class, and we need to register WebSocket.register. Here we already have an HTTP server object. We will just assign the closure returned by this WebSocket function to this path where you want to handle the WebSocket connection. So just like we pass get request closure or post request closure to this server object, we can pass the closure returned by this WebSocket function. This closure will take a parameter of HTTP request, and this closure will return HTTP response. The closure of this type will be returned by this WebSocket function, and it can be directly assigned to the subscript notation to the HTTP server. So let's jump into the demo. See, in this, we just have to import Swifter, and there is no other thing for WebSocket because it's itself, there is only one thing we need to import, Swifter. Now, as I said, we need to have an object of HTTP server class. So I created this in initializer, and then as we have called get function, post function in our case of Kitura, in this I'm just setting this path /home to my server, this closure. So this closure is actually, if you see, notice there are 2 things that I'm doing. One is I'm returning this thing, which is actually I'm passing this response to the client. So I'm passing a response to the client that the text that is Swifter up and running. If you remember, in Kitura, we also used to do the same thing. We passed using the response to the client. We use the response object and we pass a text to the client whenever there is a get request. So in the get function, I pass that closure. And in the post function, I call do something with the request body. In this, again, I call this request, I took out the body out of the request, and I send it to my function, request data. And then you can do anything with this body. So you can see, this is the key thing. Like in the same closure, I am handling both the get request and the post request. So this request.body will be nil if it is a get request. Then I am going to pass the nil data. So this function is going to do nothing. But if there would be a post request, then there will be a body, and if there is a body for the request, then I can use that. And in the case of get request, this thing I am passing in post request, it doesn't matter. In get request, this will be shown when I will call this from my client, from my web browser or any other client. So let's see that first. It comes up Swifter up and running. So you can see now my Swifter server is up and running and the home path. So that's how simple it is to use Swifter framework to create a server. You just have to create a server. You need to set up a closure which will be executed whenever there is a get or post request to a path, and you need to start the server. Now this line server.start, I have called the start function, but as I said, this will return immediately. So if I will not implement this, if I will not say the sleep thing, this server.start will return immediately and this function will also return immediately. So then my server will basically stop working. This is not a very good way to block this function from returning. I just add a sleep of 100,000 milliseconds. It's better if you can actually use there are other ways like dispatch functions and all, where you can actually block your call so that your function will not return immediately. So that was handling client HTTP REST API connections. Now WebSocket thing is pretty straightforward because, as I said, like there is nothing you need to do. You just need to implement this WebSocket function, where in the first parameter I pass this closure, which I'm saying, okay, I will write the text. Same, I'm writing the binary because it's on binary format. In the Pong, in the connected and disconnected, basically you all can implement these closures similarly as we did it in case of Kitura. So that's pretty much it. Kitura, as we can see, is very lightweight and it takes even less number of lines of code to set up a server up and running. Now, the last thing that I'm going to talk about is server-side Swift, using it in our UI automation testing. So I did it in my project in Mercari. I can't show you the code itself, but I can tell you what was the problem and how I did it. So what I need to do was I need to write some UI automation tests. Why I need to do that? I need to test whether an event, a client event, is being sent to our backend server or not. So it's a kind of, you can say, end-to-end testing, that if something happens in the client, the event is being sent to our backend server or not. And when this will happen, whenever a user will tap a button inside an iOS app, maybe tapping on search bar, maybe tapping on button or anything. On those cases, we need to send events to our backend server. So we need to test that. We are sending that to a backend server, but we need to write test for that thing. To write the automation test, which runs automatically. So now how part I will explain that how I did that and how server-side Swift is used in that. So first of all, there are few steps to understand that. First thing is that you should add a string it's not mandatory to use is UI test, any kind of string in your launch arguments of app when you are running the tests. So basically in the launch arguments in the tests file, you can add this string. Then also while in the tests file itself, you will create and start a server using the Swifter library, as I mentioned. It's very simple. I included that using Carthage framework. I just included this library. I created a very basic server on localhost, and I start that server as soon as I start running the UI test. So when you run the UI test, the first thing, my server is getting started up and running. Now, as I said, when the automation tests are running, automatically your screens are getting ahead because these are automation tests. So no manual action is happening. Automatically the buttons are getting tabbed. You are going to the next screen and that. So suppose my target button, I tap on that. Now in the actual code, the event will go to the real backend server. But I put an if condition that if this process is not an actual one, if it is a UI automation test process, that's why I added that string in the launch arguments of an app. So I will check in the process info, in the arguments of the process info, that if this is a UI test process, then if that argument contains is UI test, then I know that this is not the app running manually, it's running by automation test, because I found an argument is UI test in the arguments of process info. So at that time, instead of sending an event to the actual backend server, I will send an event in the body of the post request to my Swifter server that I already started up and running when I run the UI test. Now, when I receive that event on my Swifter, as you know that I have shown you in the demo part that we have a closure that we can run whenever we receive a request. So my Swifter server receive a post request with a body. Body is the event. I will check that event on the Swifter server, that event is the one which I was expecting, the values in the event are correct, and if it is that, then our test is passed, otherwise failed. So that's how I have written the automation tests for events checking. That is event being actually sent to the server when it should be sent, and is the event correct. So that's how very basic use case of server-side Swift using Swifter library in the UI automation test. So in the end, that was pretty much it. There are 3 things that I think that we learned today, which is HTTP, REST APIs, and WebSocket connections using Kitura. HTTP, REST APIs, and WebSocket connections using Swifter library, and using the server-side Swift in UI automation tests. So I use Swifter library. I haven't used Kitura because it's a very heavy framework, and my use case was very small, so I used the Swifter library. This can be the one use case of using server-side Swift on the client side because of doing the UI automation test. That was all from my presentation. I hope that you get to learn a bit about the servers, not a lot, but at least a bit about the server-side Swift and how it can be used in UI automation testing. So thank you so much for watching this.